Hey guys, this is Mrs. Mindy, and today I'm going to quickly tell you about converting temperatures because in this class you may have to convert between the three major temperature scales: Fahrenheit, Celsius, and Kelvin. It's not a big deal, but I'm going to go over it anyway. Okay, now here's something that is kind of a bigger deal. Heat is different from temperature. And in regular life, we talk about them sort of like they're the same thing. But like in science, a lot of the time, there's a higher level of precision between these words. So temperature measures how much energy is in a system. So it's kind of like a state of being, is temperature. We've talked a little bit before about how temperature can also be thought of as a speed of the particles moving. Now, heat is different. Heat is energy transfer between things. If there's no energy transfer, we cannot pick up any heat. So it's the movement of the thermal energy. It's a slight difference. Here's another thing. There is no cold. There is no cold. Cold is not a separate thing. There's only energy leaving your body. That is your sensation of cold. If you're talking about anything that is like, oh, it's cold out today, you mean that the temperature is lower today. Cold is not like a separate thing. Cold does not move, only heat moves. Okay? So just wrap your head around that. That's a human construct, is the idea of cold as a separate thing. Not really true. There's only lesser and greater amounts of heat. Fahrenheit and Celsius are both based on water boiling and freezing. And this is just kind of cool thing because it shows that like over, many hundreds of years, scientists have thought there's something special about water. Like lots of things are of our units are based on water. So, for Celsius, the freezing point of water is 0 degrees Celsius, and the boiling point of water is 100 degrees Celsius. For Fahrenheit, it's 32 and 212, or 32 for the freezing point, 212 for the boiling point, which these seem kind of crazy and arbitrary, and there is a reason for it, but it's also kind of a crazy, arbitrary reason. Um, but this 180, because 180 is kind of like one of those magic numbers in Western society too. You know how there's 180 degrees in a triangle, and it's sort of like it's a big thing. That's part of why it's called degrees. Okay, that's just sort of some science trivia. Okay, so converting between Celsius and Kelvin. This is easy. So Celsius and Kelvin have the same degree size. So like the little increments are exactly the same. The only difference is that Kelvin is 273 degrees less. Less. Now that is because of absolute zero. Because remember before when I was talking about how there is no cold, and the thing that makes it seem funny with Celsius is that you can get to zero, like there's negative degrees, and negative heat doesn't make any sense. There should only be like heat or no heat. There's no negative heat. That the meaning of negative heat kind of doesn't make sense. And so in some of the math we're going to have to do in chemistry, it's not going to make sense because the concept of negative heat doesn't make sense. So that's why there's Kelvin. It's because Kelvin zero is absolute zero. There's no heat at all is 0 degrees Kelvin. Okay? And that kind of makes sense. Zero should be where there's none, right? Okay, but Celsius is older. And we like the size of the degree, but we just bumped it down. Okay? So when you're converting, if you have if you have Celsius, you're just going to add 273 to get to Kelvin. Okay? And the reverse, if you have Kelvin and you want Celsius, you just subtract 273. Okay? Because remember that the Celsius number is always going to be higher, right? Because the zero is so much higher. I'm not sure if that made sense to you, but you can at least see these, easy equations to deal with. Okay, for Celsius to Fahrenheit, it's slightly more tricky, but again, it's just an easy equation. So if you like to memorize stuff, here's what you memorize. I want to point out, well, let me just say it. So 1.8 Celsius plus 32 equals Fahrenheit. And when you're writing this, you don't have to write this little degree thing. Um, but like that's not going to be incorrect in your answer or anything if you don't do that for me. I want to also point out that this equation and this equation are exactly the same equation. They're just smooshed around so that either Fahrenheit is on one side or Celsius on one side, depending on what you want to find. Either of these would work if you just plug and chug. Okay, you just plug in what you know from the problem and figure it out. Now, if you want to conceptually remember this, so like this, I have a hard time remembering things like that. So I like to know, how does it work conceptually, because I'm less likely to forget the concept. So if you're that kind of person, listen up. Okay, for the size of the degrees, 100 degrees Celsius is the same as 180 degrees Fahrenheit. So that's something that you have to remember. Yeah, maybe this is easier. It's easier for me. I don't know. So if you say the conversion unit between 180 degrees and 100 degrees, that's 1.8. Okay. 1 degree Celsius is the same size as 1.8 Fahrenheit degrees. Okay. Which you can remember because 200, this 180 is bigger. So it's cutting it into a bigger number of pieces. So each little piece is smaller. But they also have their zeros in different places. So that's kind of weird. So to adjust for where the zero is, you're adding 32 when you're converting to Fahrenheit, because 32 degrees Fahrenheit is freezing. So that's like the 0 point. See, so this is the exact same actual amount of heat, like temperature. And I mess those. I confuse those two in my head. I have to concentrate on that. So 0 degrees is the same as 32 degrees in the amount of temperature there is, in the amount of energy that there is. It's exactly the same. This is this human thing that we put on here, calling it these different numbers. Okay, so you're going to add 32 when converting to Fahrenheit, subtract 32 when converting to Celsius. Again, if you just like knowing the equation and going on with your life, that's fine. I'm not going to make you explain this out. This is only if this helps you think about it. Okay? Okay. That's it for today. And you'll be practicing some questions on this soon.